Alright, draft physics video. This one for the message board again. Gravitational lensing, kind of a monstrously onerous subject. Maybe I'll show a couple of the images, and I don't know if there's a point. Because there's no real, I can't find anybody who does any explicit mathematics explaining how any of this stuff could possibly be interpreted as gravitational lensing. But, that's the state of science nowadays. Alright, so the first argument I would make about the idea of photons being bent is that photons are kind of misunderstood. They're force, like magnetism and like gravity itself. And forces have been sort of known to obey this rule of superposition, where this principle, right, that's what they call it, where the forces don't interact with each other. You can't bend gravity with gravity. That's why Newton's equations don't put in there something like the bending of the gravity equation. And you can't bend like magnetism or something like that with gravity. You can't, these things don't, they can't, force can't affect force, is how I restate the principle. And so here you have this one example of photons that can do this somehow. Somehow they are affected by gravity, and yet they're not affected by magnetism, which is technically the concentrated form of gravity in a sense. And they're only affected in perpendicular movement. So you can't slow a photon down. You know, they used to talk like photons can't escape a black hole because the gravity pulls them down. And then they thought about it and said, well, they better not say that because that implies that Earth's gravity should affect photons, and it doesn't. And so they had to change that story. And so now what they say is light gets caught in an orbit. Okay, or inside the black hole. Again, it bends into an orbit. You see, it doesn't, it tries to leave, but it bends into an orbit somehow, even though it leaves in a straight line. So, but I guess when it leaves, it somehow is leaving always crooked, so it always gets caught in a perpendicular gravity well. So anyway, it just seems like they're reaching to try to find a way to make photons behave differently when they're really in something called gravity. So anyway, they don't get pulled faster and they don't move slower. And it just seems kind of logical that if you can move them side to side, you could slow them down or speed them up. Sorry, it's like cat's having trouble clearing. It's got a, it's dying is what it's doing. I just hate it. Anyway, so the point would be made is if they can be moved in one direction, sideways, why not forward and back pressure? Alright, so and I did the light stuck in black hole thing. So let's get to the evidence for lensing. So this all started with Einstein's theory, which was the relativity theory, which basically argued that light would spend twice as long in terms of the time if it went through gravity. So it would be in the gravity for twice as long as previously calculated, and therefore there would be more time for the gravity to have an effect and therefore be able to bend the photon. So it was Einstein's speculation that we should be able to observe the effect now because there's enough gravity, in the sense that there's enough time. The photon's essentially speed is cut in half by doubling the amount of time because of this bent line, even though the photon doesn't spend more time, obviously. It just, by Einstein's theory, though, it does, from its perspective. It spends twice as long in the gravity. And so therefore there's this opportunity for it to be bent by semi-weak gravities like the sun, our sun. So this Eddington guy, did this experiment to try to verify it, and he really wanted to verify it. So let's understand he was quite prejudiced going into the experiment. And the idea was that you'd use an eclipse to block out the sun, so then the atmospheric scatter would allow a telescope to see an object being made visible in a wrong location because of the lensing. And the experiment was far from perfect in how it was conducted, and how the weather and everything else were not on their side, and so one could argue that the results are far from conclusive. It took over a year for the two people doing the experiment, had conflicting results, and they had to negotiate a settlement, so to speak, on what the truth was. It's quite sloppy. Okay, efforts to repeat the experiment on different eclipses have all failed, because yeah, it's a difficult experiment. You got to have the good weather, you got to have the right atmospheric conditions, blah blah blah, and no one's been lucky. So it hasn't been accomplished. The trick is the Hubble telescope could any day it can look, because there's no atmospheric scatter, the sun's only a dot to it. So it can look right next to it without looking at the sun and see black space. So it can see things right next to the sun without the sun interfering. The sun only interferes because of the atmosphere here on Earth. And yet we don't have those images from the Hubble telescope. We have all kinds of images, but not those images of our sun lensing. So I would argue that it's probably because they can't find the image. They can't find the sun doing it. And that's why it hasn't been proven in the original form. And so now they have lots of other experiments. So there's some that have been done with radio waves and X-rays and different other kinds of emissions, not only from space, but one's projected and then received back as a reflection. And some of those have some indication of the fact that you have a frequency derivation, okay, a change, and some, this idea of what you can image out of the information. But most of it they can't separate from what might be possible, that it's just the atmosphere they're sending the signal to. So essentially the sun has a atmosphere around it of charged particles, and they can't be certain that it isn't just diffraction from the charged particles that's making the signal that shouldn't be receivable because it's diffracting off of those particles and bending. That wouldn't be lensing, that would be diffraction. And the indication that that might be the cause is the fact that the signals they get back are very weak. And so it does sound like it's probably just the byproduct of opportunistic scatter that's allowing you to see something that you wouldn't be able to see because of the scatter in the very thick atmosphere of the sun. I would say that none of those experiments are anything like hard evidence of anything called gravitational lensing, where they could make a clear distinction and say, we're certain this is gravity, and we're certain it bent light, or it bent a consistent force sent or received. Alright, so it's really important to understand this problem of the atmosphere problem. Like anything that has a lot of particles around it, a lot of junk, isn't going to be a good source for lensing. And the other problem is the inverse square law. And so I guess it might be appropriate to start drawing pictures. See, lensing is complicated in the sense that the idea that you could have a little spark of gravity that would bend light makes some sense. But the idea that you have enough gravity of the same depth, a consistency, to actually image something is a little more complicated, because gravity doesn't really do that. Gravity has gravity obeys, so the lens in gravity, it obeys the inverse square law, which creates a very unpleasant kind of line, okay, in terms of the degrade of the gravity. And so you kind of have to appreciate that this is the lens you're going to be looking through. And I'm pretty certain you've never seen a glass lens in a camera or anything else that looks like that, because that kind of lens isn't going to give you any kind of image resolution. It might give you some kind of refractor, it might give you something like light, but it's going to be highly distortive of the image. One would suspect that you wouldn't be able to create a rich image out of such a lens. And so that's one problem I've not seen dealt with anywhere, is that, you know, they always draw these as, you know, so, oh, here's the simulation, and they just put a big normal round lens in there and just say, look, this is, look, the thing over here, and it goes through the lens, and yeah, this is the lens. You know, it's really, these are kind of important details, and I'm just saying there's no exploration of any of these details. And so I've also pointed out in the past, I might as well get to it while I'm doing the drawing part, that gravity's, you know, some people don't really understand how gravity works, but gravity really is mass related, and it's the thickness of a mass, you know, the density of the mass will dictate the gravity in a location. So we always deal with things that are round, spheres, and so the mass is consistent from every point, and so there's no argument about where the more gravity is. But the fact is, if you shape an object and you had it in space, it would have a lot more gravity over here than it would have over here. It would be like 4 or 5 times weaker coming in this side than this side. And galaxies are like that. Galaxies have their matter distributed. Now the other problem with galaxies is, so the point would be made is that if you were going to anticipate being able to lens, the idea would be to have the light go through the most gravity in the most amount of time. So take advantage of time and take advantage of the thickness of the gravity. So you wouldn't want the light to go over the top of the galaxy. Say this is a galaxy, you know, brighter spot in the center and all the swirly bits around here. So obviously the top and the bottom would not be the places you would expect to see lensing, because it would be the weakest possible gravity. You'd expect to see the lensing in the thicker parts, but they're further away from the center bit, which is a real problem. But even, let's say, you could argue that I would argue that most of the gravity in a galaxy is distributed, so it is in the arms of the galaxy, not the center of the galaxy. But as I'll explain in a minute, that's also not going to work for you. But let's just say, for the sake of argument, you definitely would have more gravity here than here. And so the idea would be to, say if this is the galaxy flat, the idea would be to have the light go this way, perpendicular to the planes, flat to the plane of the galaxy, to get the most gravity in the most amount of time. If you come out of the galaxy, you go through the galaxy. If the galaxy is facing you and you're coming out of it with the light, that's the weakest possible gravity, because you're in it. The galaxy is thin, remember? So the thin galaxy, you'd only be in the lens for the shortest period of time. You're just shooting right through it. Where if you go this way, you're in the thickness of the gravity for the longest amount of time. So anyway, it's the weakest it's the least potential for lensing, is a gravity that's pancaked this way. And many of the gravitational images that are supposed to be lensing from galaxies are this way. Now, I haven't seen any this way. And then, you know, with little dots at either side. So the image that we should see most of the time from gravitational lensing is something like this, or something like this even, you know, something inside the galaxy, but with a galaxy on edge. Alright, the other problem is that gravity really does depend on the density of mass. If the sun is not very dense atoms, okay, it's hydrogen and helium, so it doesn't really have as strong as gravity as people think. It's only 8 times what it is on Earth. And so it's not that incredible considering how huge it is, okay? So it's 70 meters per second, and on Earth it's 10 meters, so, you know, 7 or 8 times, 8 times stronger. But the sun is, you know, just huge compared to the tiny little Earth. So density matters. And so when you take objects like a galaxy, you're talking about suns that are pretty far apart, the matter is so distributed that the inverse square law basically says that the gravity from this little object would be 1/10,000th of its strength. Just right there. I mean, it weakens very fast. This curve, this curve probably isn't even fair to it. It's, half the distance of the radius of the object, of the diameter of the radius, will get you 4 times less gravity. I mean, so, it's 8, 16. It diminishes very rapidly. So just like 4 suns away from the sun, you're already at less gravity than that's on Earth. Just 4 sun diameters from the sun, you already have less gravity from the sun than we feel here on Earth. So there's no mathematics that can make any of these images make any sense, because you need incredibly strong gravity to bend light. Light is moving 160,000 miles a second. 4 million meters a second, 3 million meters a second. There's no way to make sense out of this. It's an incredibly fast and light object, and you need intense gravity to bend it, because it's past you so fast. It's, but the important thing is it's past you so fast. Acceleration is in the entire gravity argument. I shouldn't even mention how small it is or light it is, because it's irrelevant. But the point is, it's moving so fast that you have no chance. Anyway. Alright, so I think that's enough of that element of physics. But I'm just saying that the distribution of galaxies is so thin in the density that you couldn't even find a place anywhere in a galaxy except right next to one of the suns in the galaxy. And it'd be just such a tiny lens, you'll never see anything it lenses. So there's no location where you can make one of these lenses. It just doesn't exist as a fact of any kind of not made up physics. So unless you use something contrived, like I'll talk about later, dark matter, you have no hope of calling this gravitational lensing. It's not by any normal kind of gravity. You have to create a completely abnormal and completely contrived new gravity to make it make sense as lensing. And even then it still doesn't make sense, because you'd have to explain why your artificial gravity isn't affecting anything else around it. Why isn't everything falling into that artificial gravity? I mean, these lenses are not in places where you see a bunch of action, where you see a bunch of stuff moving. There's no evidence of a lot of rapid movements. So there's anything collecting or coalescing at these lens locations. And these lens locations have to have intensely strong gravity. It just makes no sense, and it really, you just got to say there's something so fundamentally wrong with physics that they haven't fixed this. That they just keep talking this up when there's so many problems. Just completely, I mean, they're huge, gigantic problems, and they don't fix any of them. They just keep pretending this makes sense, because the public isn't going to pay any attention to the math. They're not going to pay any attention to this argument that you can't make any rational math that makes any of this stuff work. Okay, so galaxies have distributed gravity, not centered. I've sort of already gone over that. I guess, well, there's more here. The problem of atmosphere, okay. Problem of the lens shape, so I went over that. This shaped lens is not going to give you anything close to a good image. You just kind of have to understand that lenses work because they change their thickness at exactly the right location for everything to add up. And this has exactly the opposite change. So everything won't add up. The left side will be going where the right, that it'll switch the sides, it'll switch the amount of angle that the things are reflected at. It just can't possibly make a wide image resolvable. It can't possibly project an accurate projection of an image. All right. Cosmic lenses are too large and too wide, so that's just the argument. There's no gravity where they say there's gravity, and that's just a fact by any rational understanding of gravity. Again, like I said, unless you just make up fake gravity, there's no gravity there by Newton or Einstein. Einstein wouldn't say, oh yeah, that's exactly what I theorized. Einstein would look at these cosmic images and he'd say, that has nothing to do with any theory I wrote. And yet they keep claiming Einstein has something to do with this crap. Should be more where there isn't any. Okay, where there are not, I said. So obviously there should be lenses in places we know there's lots of gravity and there's just no lensing happening, and we know there's a whole big pile of the universe behind the thing, and no matter how many times we look at it, it never lenses any of that stuff, and it should. And less where they are. So yeah, there's all the lensing images seem to be in places they just shouldn't be. More small spots. There should be more little lensing dots. So there should be lots of little dots around places, because the little dot lens is so much more probable, where you just get a little tiny flare because of a heavy spot of gravity and just the right amount of light goes through to make a bright spot. And so you should see lots of little spots, and there's no indication of spotting. Alright, wrong gravitational configuration regarding galaxies. So that's, I've explained that the galaxy has more gravity on its plane than off its plane, and if you go through the pancake you don't hit much pancake. If you go through the pancake the flat way, you drill through a lot of pancake, but if you go through it this way, you don't get much pancake. Anyway, galaxies have distributed, not centered. Okay, non-solid objects have weak gravity. Non-solid objects. So yeah, again, that's just the idea that as soon as you distribute it, you weaken it. If I cut the sun in half and made two spheres sticking next to each other, not smashed into each other, just two round spheres next to each other, I've substantially degraded the sun's gravity, because now the real gravity sphere is going to be the combination. I've widened the diameter essentially, and so the gravity on no surface will be stronger. It'll only be weaker. The only place it would be exactly the same is one thin line going right where the two intersect. And that's the only line that would have the same gravity. Have a little more gravity actually. Anyway, okay, yeah, think about that. Problem of dark matter as a contrived fix. Okay, I don't want to go into a whole bunch of stuff about dark matter because it is just so silly. It's like Huygens. It's even less than Huygens because it's just such a sham. I mean, there's absolutely no evidence that it exists. It doesn't make any sense really that anything like this could possibly exist, that you could break all of the atomic theory we have and create essentially invisible matter that doesn't reflect any forces, that isn't affected by any forces, but somehow still produces gravity. I mean, it breaks every rule of all the physics we have, just about. And it only exists to fix mathematical problems. I mean, you know, if that's not a god of the gaps, what the fuck is that? It's just made up because you can't find the right answer, so you're just going to make up an answer. And I mean, scientists shouldn't do that. They really shouldn't do that. It's a cartoon character. It's fake evidence. It's cheating. That's all. Yeah, it's cheating. Yeah, there's nothing else to say about it. Alright, so let's look at a couple of these images. You know, they're just so bad. so very bad. Alright, so this one. I just found, I was just farting around. They don't give you any high resolution images, which is really irritating. They call it a high resolution image, but it isn't from the Hubble telescope, and it's 58 whatever bytes. It's just, you're like, oh come on, you're telling me you don't have a better picture than that? Fuck you. Anyway, so it looks like two galaxies crashing into each other, but apparently they think these are galactic clusters. Okay, so, which I'm not even sure that's right. So they're saying that these 4 dots are being lensed from a supernova way, way behind this cluster. That's their theory. Now, for that to happen, first off, the lens has to be facing you perfectly. Alright? Because each one of these locations has to have exactly the same gravity. They're not even, of course. And the lens has to be facing you, and the object has to be exactly straight line between you, the lens, and the observer. And it seems obvious that this is canted, so it doesn't even make sense on its face. You can't turn the lens and see the same thing. You can't do it that way. I can't put a supernova over there and then have this lens crooked and then see the supernova over there as 4 objects. I could see it as 1 maybe, but you can't do this 4 object thing. You can't do the full circle thing if the lens is crooked. Can't do it that way. And obviously these things aren't where they should be. This should be facing us. It should be across, for Christ, for fuck's sake. You can't make some other shape and then say, that makes sense, it works. Alright, secondly, they're huge. So that means the lens has to be really dense. So it's not like, you can't do this. You can't have a curved line of r squared and do this whole object. That won't happen. So this whole object appearing in this lens means the lens has to be the same gravity for the full width of that thing. Now that thing could look like it looks like it's a few light years across. So somehow you'd have to have the same gravity, exactly the same, to have it come out round like that. Exactly the same gravity for, I don't know, 10 light years across? What physical phenomena can create gravity like that? Alright, number 2. The center of this object wouldn't be just this. It's something narrower than this white blob. And if that was suspected to be the gravity source. So we could say that half its diameter. So we're already probably 4 R's worth of distance. Which means we've already degraded the gravity this far out, by multiples of, it's probably 100 or 200 times less gravity, more than that maybe. So this is already getting very weak in terms of gravity. So it wouldn't even be a lensable circumstance. The gravity out here would be Earth gravity maybe. That's all, the Earth gravity out here. This wouldn't even be the sun's gravity out here. And yet we have this huge gravity that's producing, and it's so strong, like I said, that it's producing all of this light. So that much light is actually being collected by the lens. For the lens to collect the light, it means it has to have a lens covering a lot of distance, because it has to catch every single photon coming at every different little angle and bend it the right way. So to make a bright image, you need a lot of coverage, lens coverage. And I'm just saying by the size of these lenses, we're just saying that a lot is the distance of this object. And the distance, if this is a galactic cluster, you're talking about this may be 100 light years across. So it's 100 light years thick of gravity, of basically the same exact gravity. Doesn't diminish. It's not, we don't see any indication that they're much brighter at the one edge than the trailing edge. No indication of that. It fundamentally defies reasonable physics to say those dots are being created by lenses. It's just wrong. And I'm not even, okay, so now I'm going to claim I'm not an expert. But, you know, and that works both ways, because then they'll just say, well, that's because that's why you don't understand, it's because you're not an expert. Well, I know the smell a dog do, okay? I don't need to be a veterinarian to be able to smell dog shit. And I'm just saying, this is dog shit, and these people are selling it like it's cotton candy or, you know, gummy bears. This is dog shit. Alright. So now we'll go back to the evil Puro and his little smiley face. So I did this one before, but when you blow this image up, it becomes even more perceptually unavoidable. Okay, that this can't be a lens either. I mean, first off, the arcs aren't arcs, they're warped. They're not in the same plane, which they have to kind of be, and you can almost see that they're crossing over each other. I mean, there's a clear indication that this one is forward of that one. You can't do that with a lens. And again, the lens, it has to be huge, wide here, of the same. Look at the detail you have in here. You can't get that detail unless you have a huge section of lens that's a traditional lens, where it's going exactly the opposite way of the inverse square lens. So to see it that clearly, you need this shape of lens. You can't do it with this shape of lens. Can't be done. And so, you know, there is a slight indication of some mirror here, in the sense that this does look a little bit like this, and there's a blob at the end, and, you know, kind of, but there's nothing like that over here, except for this color. But there's color over here, so that doesn't mean anything. But there's just no source. There's no indication of any hugely strong gravity in any of this location. And so it really can't be being created by this little dot, unless, as I argue, it's not a lens. And the fact is, the little dot blew up, and these are the remnants of what blew away from the dot. And this one's moving back, this one's moving this way, and this one's moving that way. And that's why they don't appear to be a perfect sphere, but they really are, because they're real things, not lens things. And again, lenses can't create three-dimensional objects. It can't create a gravitational lens. Can't give you the illusion of something going away and something coming forward. So I mean, it's, you know, and the brightness. Okay, that this is another just huge giveaway. Look how bright all of this stuff is when you add it up. So here it is, a little tiny shred of lens, and look how bright the image is. It's just not possible for a lens to do that. I mean, if I black out the center of this, you know, and I just have little shreds of the lens where you're going to see, you'll see it's not much light gets through. And we're talking about a tiny object getting lensed. Tiny object. And look how much, when you add up all this light, it's more light than the object could possibly be producing, that the lens could actually be capturing. So it just doesn't make any sense. Things don't get brighter going through a lens. They get bigger, but they don't get brighter. You know, brighter than they actually are. I don't know how to say it. You can't make more photons. You can only collect more photons. And again, these lenses aren't collecting photons from the entire. The entire lens isn't even working. It's only one little part of the lens that's actually lensing. So there's no way to make sense out of this. There's no indication of the gravity that exists. There's nothing to justify how the strength of that gravity isn't sucking up everything in this field, in the sense that, well, these yellow objects are likely in a completely, you know, they're light years away, so they have nothing to do with this image. But, you know, it just doesn't make any sense. It's not lensing, and it can't be defended as lensing, and it's just wrong that that's what they're doing. And lensing, as I'm pointed out with my other arguments, it just violates so many things that you really should be sure before you just keep selling it. Try to reassure everybody it's real. Because I don't think it's all that critical to Einstein's theory of anything. I mean, it's sort of critical from my perspective, because again, this whole idea of force affecting force, it's a violation of a fundamental principle. And there's just no reason to believe photons and gravity have some kind of special relationship. They're just forces. And if other forces don't mix, there's no reason for gravity and light to mix. Alright, it's probably enough. So, yeah, it's not an important, this isn't like fundamental to my theory of physics at all. I mean, lensing is just not very useful. I mean, it's not saying that we can't use it if it existed for some purpose. But there's no evidence that anything deliberate has ever been done in that respect. Where they've deliberately moved a lens by, angling. See, these images too, the Hubble telescope can view this thing from 2 different angles if it chooses to, because of the rotation of the Earth around the Sun. So they can wait for a different, it's 4 months and take another picture of this, and then you'd really be able to tell which features in here are real features, which things are connected to each other. But they don't do that. Well, I don't know why there isn't Hubble images. They should all be done that way. They should triangulate every one of these images so we can tell which things are far away and which things are close. That's the easiest way to tell. I don't get why they don't do that. I really don't get it at all. Alright, anyway. But I don't know why they're not using the Hubble to see everything get lensed as on the edge of the Sun. They could just have the Hubble follow the edge of the Sun, and they should be able to see the entire field of the universe get lensed as it goes by. They should have a movie of it. Alright, anyway. Until next time, and such.